Well, hello friends, welcome to the lecture 2. In this lecture, we are going to talk about group. So first of all, what is the definition of group? A group is a set under some operations if it satisfies the following properties. So we have mentioned 5 properties over here and it is denoted as G, dot, where G is any set and this dot is any binary operator. So while I am explaining you any of these properties, this dot is any of the operator and I will be speaking it as dot for conveniency. Okay, so first of all, let us talk about closure property. Closure A1, right? So closure property says that for any two elements A comma B belongs to G, which is our set, then C is equal to A dot B, which also should be belong to G, our set, right? Now next property is associative property A2. So for any three elements A, B and C which belongs to G, then A dot B dot C must be equal to A dot B dot C. Alright. Now third property, which is identity property A3. So for any element A belongs to G, let E be its identity element, then E dot A is always equal to A dot E. Now the fourth property, which is inverse property A4. So for any element A belongs to G, A inverse dot A should always be equal to its identity element. Well, don't get confused because we are going to talk about the example also in the next part. So let's talk about now the fifth property, which is commutative property A5. So for any two elements A comma B belongs to G, then A dot B is equal to B dot A. Well, I have explained you all the properties which should be defined in a group or which defines a set as a group. Alright. Now, if in an example only the A1 and A2 property satisfies, which is closure and associative, then that group is called as semi-group. If A1, A2, A3 and A4 all these properties satisfies, then it is known as group. And now if A5 also gets added in this A1, A2, A3, A4 and A5, then that group is known as Abelian group. So now let us solve an example. We have a group which represents n as the set, natural numbers and operator as addition. So we have to find out that is this a group or not. So n set consists of 1, 2, 3, 4 and so on. Alright. Now before explaining that is the how many properties satisfies this set, I want to tell you that the identity element E, so for addition it is 0 and for multiplication it is 1. Alright. So now in this particular example, it satisfies A1 and A2 property but not A3 and A4. Why? Because A3 property and A4 property consists of identity element, and for addition, as I told you, that identity element is 0, but 0 is not consisted in our natural set. So this will not satisfy A3 and A4 property. So therefore, as I mentioned you earlier, that if any group satisfies A1 and A2 property, then it is known as semi-group. So this example is not a group, it is a semi-group. Alright. Now let us take an example for an integer. Alright. So the another example is Z4 and the operator is again addition. Alright. So now Z4 is equal to 0, 1, 2, 3, which we taught you in the lecture 1. Alright. If you forget, then refer it once again. So for this, now we check all the properties. So A1 property, which is closure property. So in this set, in this domain only itself, we have to take our numbers. So we choose 3 plus 2 and we also have to do the modulus of the Z number which we have used in our example. Alright. So the number we choose for A and B are 3 and 2. So 3 plus 2, 5 mod 4 gives 1. 1 is in our domain, so it satisfies. Number 2, which is associative property. So we took 1 plus 3 plus 2 mod 4, or we can take 1 plus 3 plus 2 mod 4, which gives answer 2. So 2 is also in our domain, so this property also satisfies. Now A3. So for A3 we have identity element as it is addition, so we will have 0. So 0 plus 1 mod 4 gives us 1, and as 0 is included in our domain, so it also satisfies. Similarly, A4 also satisfies and A5 also satisfies. So as I taught you earlier, that if all the properties A1, A2, A3, A4 and A5 are satisfied, then this particular group is known as Abelian group. Alright. And now we would like to give you few examples as your homework, which is this written over here. So you try to solve it by yourself, and if you have any doubt, then please comment in our comment section we'll be happy to help you. Thank you.